Okay, here's another practice problem, and this is in vertex form, x minus 3 squared minus 5. And we want to graph it and answer all these questions. So again, hopefully you got this graph paper off my classroom site, so you can just take a look at this, write it down and then try it, and then pause your video, try it, and then come back and play and check your answers. So try to do as much of it as you can. We've already done some examples like these in vertex form, so you could follow that example if that helps you, and see if you can do this on your own. So pause the video and I'll see you in a moment. Okay, hopefully you paused it, did the problem, got it all right, and came back. So let's just double check this and see. So first of all, opens up, well, this is the sign in front. There's always like an A in front of this, and that's positive, so it's going to be shaped like a U because it's positive. If it's negative, it's shaped like an N, so that's easy. So it opens up, so that's nice. No problem there. Now we want to find the vertex, and now this is in vertex form, so we're in good shape. The vertex is going to be what? Opposite sign, same sign. So 3, and negative 5. So there's my vertex. 3, negative 5. And I can put that right here on the graph if I want. 3, 1, 2, 3, 4, negative 5. So there's your vertex. So you've already got that in. Okay. And we know the axis of symmetry. This is x and this is y. So the axis of symmetry in vertex form is really nice to you can get the vertex real fast. So x equals 3. That's my axis of symmetry. And since it's shaped like a U, have a minimum, so you want to circle minimum, and that's going to be at the y value, negative 5. Okay. So we can mark the axis of symmetry here, and we just go right down to the vertex. So there's our axis of symmetry. Now we can use our shape equation also when we do these, and we can get our points, but they want the y-intercept and the x-intercept, so we have to find this stuff anyway. So let's do that. Now the y-intercept is when the x is 0, and the x-intercept is when the y is 0, so you can put those in. So this is a little bit harder. So if we want to find the y-intercept, the x is 0. So we know y equals, and that's going to be, if I put 0 in for the x, 0 minus 3 squared minus 5. And that's going to be negative 3 squared, which is going to be 9, minus 5, so that's going to be 4. So that wasn't too bad, wasn't too difficult. So that's going to be 0, 4. And I can put that point in, 0, 4. And I know I got a symmetrical point, 1, 2, 3 on the other side, so that's going to be the point 6, 4. So that's my symmetrical point. So now if I had to sketch it, I could sketch it pretty nicely right there. Now let's try to find the x-intercept, so that's going to be when the y is 0. So this is y, so I'm going to set this equal to 0. This is y equals that, but I want y to be 0. So 0 equals that, or that equals 0, so I can write over here, and I'll do this down over to the corner here. There we go. And we'll write down x minus 3 squared minus 5 equals 0. And we did some quadratic equations like this on your homework problem, so hopefully remember that. So if I add 5 to both sides, I get x minus 3 squared equals 5. So if something squared equals 5, then that's something x minus 3 equals plus or minus the square root of 5. So x equals 3 plus or minus the square root of 5. So x is approximately 3 plus or 3 minus the square root of 5. Now what are we going to do for the square root of 5? Well, we can do our approximations, and we did these before. So I have these from another problem we did, so we might as well just save a little bit of time. But you could write this out. You know the square root of 4 is 2, 5. And the square root of 9 is 3, so we go right between 5, 6, 7, 8. We divide that up. That's the one that worked out really nicely to 2.2, 2.4, 2.6, 2.8, and 3. We evenly divided. So we kind of interpolate and we say, well, the square root of 5 would be about 2.2, so I'm going to use that. So that was from a previous problem, but you could do it again. It's an easy technique to interpolate. That way, if you don't have a calculator, you're in good shape. Okay, so approximately, so 3 plus 2.2. All right. And that's going to be equal to 5.2. And 3 minus 2.2, which is just going to be 0.8. So those are your intercepts. 5.2 and 0.8. And again, like I said, you could always just, like I mentioned before, you could just write this out somewhere. And you can pause and put that on your paper if you want to make sure that you remember how to do that. We know that the square root of 4 is 2, the square root of 9 is 3, so the square root of 5 should be somewhere in between. Okay? So those are our intercepts. We could put our intercepts down. 5.20, so it's 5.2, a little bit past 5. And then 0.8, almost up to 1. And notice how this is going to be 1, 2.2, and 1, 2.2 on both sides of the axis of symmetry. So there you go. Now we're in business. Now we can also use our shape equation. Our shape equation would be y equals x squared. That means we go over 1, up 1. So I'm going to put those points in just to get a better shape. Over 1, up 1. Back 1, up 1. And then over 2, up 4. 1, 2, 3, 4. And back 2, up 4. And notice how we get some more points. So actually now we got 9 points. So we got a real nice approximation on that shape. But over here we're just going to use these values here to put into this table of values. But from your shape equation you could get a lot of extra points easily. But because they're asking for the x and y intercepts, we want to like emphasize those points. But you can use those shape equation points to get a much better take on this. And there you go. So that's a pretty good rendition of this parabola. Now what's the domain? Well, the domain is always negative infinity to positive infinity. And again, I'm going up to infinity, so the right part of my range is going to look like the positive infinity part. And the left will just be the minimum value, which is going to be negative 5. Okay, and then we'll do our vertex over here. And the vertex was 3, negative 5. And my x-intercepts were next off of these points we used over here. Then you have your shape equation points also you could use. So we got, this one's a 0.8, 0, and the other one was 5.20. And those were the x-intercepts. And then the y-intercept we got was the 0.04. That was the y-intercept. And then the symmetrical point to that was the 0.64. And you got nice 5 points that we worked on over here. So you can see we have symmetry about the vertex, negative 5 and 0, 0, 4, 4, as we go along the sides. Okay? So that's it in a nutshell, or a nutshell. All right? And hopefully that all makes sense. Now again, if there's any parts of this you didn't get, you always can go back. All right? Pause it. Back a little bit, review it, make sure you thoroughly understand this. It's a lot of little things. Nothing's too difficult, but a lot of little things. Okay? All right, hope that helps.